In this video, I want to have a look at how we can compare two different data sets. So it's often useful to be able to compare data sets. It might be things that are collected before and after an event, or it might be data that's collected about two different groups. For example, males and females, or two different classes, or two different age groups. We can use everything we've learnt so far, so all of our measures of centre, so our mean, our mode, and our median, and our measures of spread, so our range and our interquartile range. We can use all of that to compare our two data sets. So if we compare the measures of centre, that's going to help us be able to see improvement, or to compare the average of one group to the average of the other group. If we're comparing measures of spread, that's going to help us see which data set is more consistent. So, for example, we've got this topic test here. So a class sat a topic test, and these are their scores. And then a little while later, they sat a second topic test, and these are their scores in that one. So compare the results of the class on the two sets of data, on the two tests. So what we're going to do first, before we make any comparisons, is to find out all of our summary statistics. So for that data set, for test 1 and for test 2, we're going to find the mean, the mode, the median, and the interquartile range and the range. So there's quite a lot of work that goes into a question like this, and once we've got all those numbers, then we can make a judgment on them. So to find the median, the first thing we need to know is if we count up all the leaves, there are 24 scores in test 1 and there are 26 scores in test 2. So if we split that 24 straight down the middle, we're going to have 12 scores below the median and 12 scores above. So if I count up, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my 12th score is 49 and my 13th score is 50. So halfway between 49 and 50 will give me my median of 49.5 for test 1. Now test 2 has 26, so if we halve that, that's 13. So I'm going to have 13 scores below the median and 13 scores above the median. So if we count up, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So my median is between that 70 and the 75. I should have drawn my line in here to show you where my median was. So halfway between 70 and 75 would be 72.5. Okay, so that's my medians. To find my means, I would have to go through and add up. So I've got 30 plus 36 times 2, plus 38 plus 39 plus 41 times 3. Go through and multiply all of them together and then divide your answer by 24. And that's going to give us 51.5. If we do the same thing, add all of our scores together for our second topic test, but this time we're going to divide by 26. That would give me a mean of 69.8. If we're looking for our modes, we're looking for the most common. So in topic test 1, that would be 41 because there's 3 41s. And in the second topic test, my mode would be 75 because there's 3 75s. All right, so that's my measures of centre in that first table. For my measures of spread, I need my range and my interquartile range. So we already figured out where the median was, and I've drawn those lines in there. To find my interquartile range, I need to find Q1 and Q3. So for my bottom 12 scores in here, I need to find the median of those. So if I've got 12 scores here, halfway would be between the 6th and the 7th score. I've got 1, 2, 3, 4, 5, 6. So my Q1 is going to be 41. And my Q3, I'm going to look at the top half of my data and I'm going to find the median of that. And so I'm going to have 1, 2, 3, 4, 5, 6 in here. So that's between 63 and 58. So halfway between 63 and 58 would be 60.5. So then I'm going to do 60.5 minus 41, and that's going to give me 19.5 as my interquartile range for test 1. For test 2, I had 13 scores below my median, which means that halfway is going to be exactly my 7th score. So I'll have 6 scores below, 6 scores above, and exactly that 7th one right in the middle. So counting up, I'm going to have 1, 2, 3, 4, 5, 6, and my Q1 is going to be 57. My Q3, if I count from the top, 1, 2, 3, 4, 5, 6, 7. So I'm going to have 86 as my Q3. So I'm going to take 86 minus 57, and that's going to give me 29 as my interquartile range. Now your range is just the highest minus lowest. So for test 1, that's going to be 90 minus 30, so it will be 60. And for our topic test 2, we're going to have 93 minus 43, which would give me 50. So now that we've done all our calculations, we have our numbers, now we need to interpret them. So if we have a look at measures of center first, we can see that for all of our measures of center, for the median, the mean, and the mode, they've all increased for test 2. So what that means is that overall there's been improvement in the second test. Now, when we make a statement like that, we do need to be able to justify it as well. So not only do we need to say overall the grades have improved in test 2, we need to say how we know that as well. Okay, so that's having a look at the overall improvement. So we've used our measures of center to say that there's been an improvement. Now, if we have a look at our measures of spread, that's going to tell us how consistent those data sets are. So if we have a look at them, the range has decreased, but the interquartile range has increased. So one's doing one thing and one's doing the other, which could be a bit confusing. So if we have a look back at our data set, what's important is that if we have a look at this first topic test, it's to notice that we've got this outlier of 90 right at the top. And we know that the range is really heavily influenced by outliers. So the range has reduced in that second topic test, but it's not reliable because of that outlier in test 1. So what we're going to look at instead is the more reliable interquartile range. And we can see that that interquartile range has increased, which means that generally in the second topic test, the scores are less consistent. They're more spread out. So what that might mean is that some students improved more than others in that between the first test and the second test. Just realised you can't see any of that. Alright, so that's having a look at how we can compare 2 different sets of data.